Hello everyone, hope you all are doing good. I am Anjana from Learnohub, the free learning platform where you can study math, science and ICSE absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 9 Physics Chapter 5, Upthrust, Influence, Archimedes Principle and Flotation. We will be discussing the topic flotation. We have already discussed about upthrust, Archimedes Principle and relative density in the previous classes. Also, we will be solving questions from exercise 5C. Are you ready for the session? Let's begin. Now, what are the principles of flotation? So, when a body is immersed in a liquid, the following two forces act on it. There are two forces which acts on the body. One is a weight. Okay, in which direction weight will be acting? Weight of the body is in the downward direction. So, what is weight? We know force is equal to, according to Newton's second law of motion, we have force is equal to mass into acceleration. Yes. So, weight is a force which is represented by W, which is equal to mass into acceleration. Here is the acceleration due to gravity. And this is the weight of a body. Because of this acceleration due to gravity, we are all held to the ground. Okay. Earth pulls all of us with the gravitational force. This force is the weight of the body. Weight W is equal to mg. It will be acting in the downward direction. If the force is acting in the downward direction, then the body should sink, right? So, it should reach this point. So, here you can see this body is not sinking, it is floating. So, here why does the body float? There is some other force acting on it, okay. So, the first force is a weight that is acting in the downward direction. The upward direction we have a force which is the buoyancy or buoyant force or upthrust. Upward force acting as upthrust, okay. So, upthrust FB is acting in the upward direction. So, this first force that is weight is acting in the downward direction through the center of gravity G. Okay. So, every object will be having a center of gravity. So, what is center of gravity? We have discussed it before in the previous section. Okay. So, here if I need to hold this pen, if I need to balance this pen, so it will be possible only at a single point. Okay. So, at this point, I am able to balance the pen. Okay. If I am holding my finger, if I am holding the pen with my finger at this point, you won't be able to balance. The pen will fall down. So, if it is here also, the pen will fall down. But when I am holding in this way, that is, I am keeping the pen at this point, I am able to balance the pen, which means this is the center of gravity of the pen. So, for every object, there will be a center of gravity and the weight will be acting through the center of gravity. Okay. Now, the upward force, that is upthrust FB of the liquid acting vertically upwards through the center of buoyancy. Okay. So, weight is through the center of gravity and the upward force or upthrust is through the center of buoyancy B. Okay. This is the point, center of buoyancy B. The center of gravity of the displaced liquid. So, center of buoyancy will be coinciding in different cases. Okay, that is, you will be having three cases which we will be discussing now in detail. First case is when weight of the body is greater than the upthrust or weight of the body is greater than the weight of displaced liquid. So, what is weight? What are the factors on which weight depends? Weight W will be equal to volume of the solid into density of the solid into acceleration due to gravity G. Okay. Now, what is the upthrust? FB will be equal to, upthrust is the force that is exerted by the liquid on the solid. Okay. So, here FB will be equal to volume of liquid displaced or volume of solid that is submerged in the liquid. These will be equal. So, when a body is put inside it, okay, it can sink, it can float. So, if it is in a way that 50% of it is inside the liquid and 50% is outside the liquid, which means this much volume of water will be displaced. Yes, this much volume of water will be displaced. If it is completely inside, then this much volume of water will be displaced. Okay, so here the volume of solid submerged in liquid is equal to the volume of liquid that is displaced. Okay, so volume of solid submerged in liquid into density of the liquid into acceleration due to gravity. This is the upthrust. Okay, maximum upthrust is when the body is completely submerged inside the liquid. Okay, so we have three cases. First, we will be discussing when weight of the object is greater than FB dash. Then what happens? When weight is greater means downward force is greater than the upward force. Okay, so the net force will be acting downwards because the downward force is greater, weight is greater, and this net force will be equal to W minus maximum upthrust FB dash. Okay, W minus FB dash is the net force. In this case, the object, whatever we have taken, will sink. Okay, it won't float, it will sink because weight is greater. Clear? So here we are having volume of solid into rho s into G is greater than volume of solid that is submerged into density of the liquid into acceleration due to gravity. So in this case, which one will be denser, the object or water? If the body sinks. If the body sinks, then the solid that is taken will be having a density greater than the density of liquid. Volume will anyways be the same because the same object is being used. Acceleration due to gravity is also same. Okay. So here rho s is greater than rho l. Density of the solid is greater than density of the liquid. Because of this reason, the body will sink. Okay. Now one more thing. You can see that in this, you can see the object is completely inside water. Okay. Then the center of gravity G and the center of buoyancy B will coincide. Okay. If the body is completely inside water, in that case, center of gravity and center of buoyancy will coincide. Clear? Next is when weight of the object is equal to the upthrust or weight of the body is equal to the weight of the displaced liquid. So here this is a case of just floating. Okay, just floating case. So when the body is immersed, you can see that weight is acting downward, upthrust is acting upward. So here it is not sinking. What is happening? It is just floating. That is, the upper surface of the body is coinciding with the free surface of the liquid. Okay. So in this case also, the center of gravity and center of buoyancy will coincide. Why? Because the volume, the entire volume of the body is taken. Okay. Now, weight is acting downwards, upthrust is acting upwards. We have weight is equal to upthrust. Okay, W is equal to FB dash, which means they are equal in magnitude. Then what is the net force? Net force will be equal to 0. So when a body is immersed in a liquid, we know that the actual weight minus apparent weight will be equal to upthrust. Now in this case we have upthrust and the actual weight, that is weight of body in air, are equal. Okay, apparent weight is the weight of body in the liquid. Then what is apparent weight? Apparent weight will be equal to actual weight minus upthrust. Actual weight and upthrust are the same magnitude. Therefore, this will be equal to 0. That is, apparent weight will be equal to 0. So, for a body which is just floating in a liquid, will be having its apparent weight when measured equal to 0. Okay. Understood? So, this is the second case when weight is equal to maximum upthrust. So, what is weight? Weight is equal to volume of solid into density of the solid into acceleration due to gravity, and upthrust is equal to volume of liquid that is displaced. Here the volume of liquid displaced will be equal to the volume of the solid. Why? Because the body is entirely immersed in the liquid, gets submerged completely inside the liquid. So the volume will be same into density of liquid into acceleration due to gravity. So in this case, the density of solid is equal to density of the liquid. Okay, why? Because volume of solid and volume of liquid are the same. Acceleration due to gravity is same. Okay, if W is equal to Ft dash, then rho S will be equal to rho L. So densities of the solid and the liquid will be equal. Liquid that is displaced will be equal. Okay, so understood the second case. Next, the third case, when the weight of the body is less than maximum upthrust, that is the weight of the body is less than the weight of the displaced liquid. So here in this case, the body will float. Okay, that is a portion of the body is inside the liquid and a portion is outside the liquid, that is partially immersed and partially outside the liquid. So here you will be able to see that we have the center of gravity G, but the center of buoyancy will be below the center of gravity. Okay, now the center of buoyancy will coincide with the center of gravity of only this portion. Okay, consider this portion, and when you find the center of gravity, the center of buoyancy will be coinciding with it, which means the center of buoyancy is just below the center of gravity. Now here we have weight in the downward direction and upthrust in the upward direction. Which is of greater magnitude? Fb dash is greater than weight of the body. Okay, therefore the net force will be in the upward direction. And because of this, the body will not sink, it will float. Okay, this is what why the reason. This is the reason why the body is floating. Okay, it won't sink. Okay, here again we have understood that this much portion is immersed inside the liquid, which means the volume of liquid displaced will be equal to volume of this much portions of the body. Here again, when you find the apparent weight, you will be getting apparent weight will be due to this portion that is immersed. Okay, so apparent weight will be 0. So for any body, if you try to weight inside water, you will be able to see that its weight, apparent weight will be equal to 0. Okay, when it comes out of water, when you weigh, you will be having the actual weight. Okay, so this is the third case. Okay, here density of the liquid is greater than density of solid. Okay, when density of solid is less than the density of liquid, the body will float. It won't sink. It will float in such a way that a portion is inside water and a portion is outside water. Okay, so these are the three cases. From these three cases discussed, we can get the principle of flotation. So this is a principle of flotation. The weight of a floating body is equal to the weight of the liquid displaced by its submerged part. Okay, weight of liquid that is displaced by the submerged part when a body is immersed. Okay, two cases when it floats is when weight of the body is equal to the upthrust, and the second is when the weight of the body is less than the upthrust. In both these cases, the object will be floating. Okay, now the weight of this floating object will be equal to the weight of the liquid displaced by its submerged part. So how much part is submerged? Water will be displaced. When you take the weight of this water that is displaced, you will be getting the weight of floating body. Okay, so this is a principle of flotation. Next, we are going to find a relationship between volume of submerged part of a floating body, the densities of liquid and the body. Okay, so here we are considering a case. We are taking a tumbler which is filled with water. Okay, then a body is immersed. Okay, this is a floating body. The body is floating on the surface of the liquid. So here let us take volume of body as V. Volume of body is equal to V. Density of body is equal to rho. Okay, now it is kept in a liquid. So when it is kept inside a liquid, what happens? It is partially immersed in the liquid and a portion of it is outside the liquid. So when the portion of body occupies a space inside the liquid, what happens? The liquid will get displaced. Okay, which means the volume of the immersed portion of the body will be equal to the volume of liquid displaced. Let the volume of immersed part of body be equal to small letter V. be equal to V. Okay, small letter V. This volume of immersed part of the body is same as the volume of liquid displaced. Okay, let the density of liquid be rho L. Okay, now what is the weight? Weight of the body. W is equal to volume of body into density of body into acceleration due to gravity. Okay, what is the volume of body? Volume of body is V. Density of the body is rho. And acceleration due to gravity G. So, W is equal to V rho G. Okay. Now, what is the upthrust? What is the upthrust here? Upthrust is equal to volume of liquid displaced into density of liquid into acceleration due to gravity, which is equal to volume of liquid displaced is equal to the volume of body that is immersed in the liquid V into density rho L into acceleration due to gravity G, FB dash. Okay. Now, when the weight of the body is equal to FB dash, when it is equal to the upthrust, we will be having V into rho into G equal to V into rho L into G. Okay. So, G gets cancelled. Then you will be having rho by rho L is equal to small v by capital V, or V by V is equal to rho by rho L, which means the volume of immersed portion divided by total volume of body will be equal to density of body divided by density of liquid. Density of body divided by density of liquid. Okay. So, now we have the relation between the volume of submerged part of a floating body, densities of liquid and the density of body. Understood? Okay, so this is a principle of flotation. So, using principle of flotation, if we know any of the three quantities, you can find the fourth quantity. Let us take two examples. A cork of density rho S equal to 3 by 4 gram per centimeter cube. We know the density of the liquid. What is the density of the liquid? If it is water, if water is a liquid, then density of the liquid is equal to 1 gram per centimeter cube. So, the volume of immersed portion of the body divided by the total volume of the body is equal to density of the solid divided by density of liquid, which is equal to 3 by 4 divided by 1. So, V by capital V is equal to 3 by 4 or small v is equal to 3 by 4 times capital V. What does it mean? That is the volume of the body that is immersed in the liquid will be 3 by 4th of the volume, total volume of the body. Then what is the volume of body that is remaining, that is outside the liquid surface? How to find? So, the volume of body outside will be equal to total volume minus 3 by 4th of the volume. 3 by 4th of the volume is inside. Okay. So, for the bodies, 3 by 4th is inside. Then what is outside? It will be 1 by 4th. This is equal to capital V into 1 minus 3 by 4. That is equal to 4 minus 3 divided by 4. So, V into 1 by 4. 1 by 4th portion of the total volume of body is outside the liquid. Okay. Now, next example, a cube of ice of density rho S is equal to 0.9 gram per centimeter cube. So, density of the liquid is 1 gram per centimeter cube. Okay, so volume of the body, that is immersed divided by total volume, is equal to 0.9 divided by 1. Okay, which is equal to 9 by 10. So 9 by 10 is the fraction, which means V is equal to 9 by 10 into capital V. 9 by 10 into capital V, which means 9 by 10th of the total volume is inside. Okay, total volumes 9 by 10th is inside. Then the remaining will be 1 by 10th of the volume will be outside. So here if you are converting it into percentage, 9 by 10 into 100, that is equal to 90%. To convert into a percentage, a fraction into 100 just you have to do. Okay, so 90% of the ice cube will be inside the liquid and only 10% remaining, that is 10% will be outside the liquid. Okay, so this is how you can find. Just you need to know the relation for the principle of flotation. Note this point. A floating body of higher density has its more volume submerged inside the liquid. Okay, higher density. If you take two bodies, okay, you have two bodies, A and B. Okay, now these both are floating. Okay, so floating body of higher density has its more volume submerged inside the liquid, which means when you take A and B, which will be having greater density will be for B. Okay, density of B will be greater than density of A. Why? Because you can see that the greater volume of body B is submerged inside the liquid and hence experiences higher upthrust than the body of low density. Okay, so when you compare which one, in which case the upthrust will be higher, upthrust will be higher in the second case, that is B. Okay, why? Because here more force is required to keep the body floating compared to the first case. Okay, so when the body with density greater, okay, when you consider two bodies that are floating, the body with density that is greater will be experiencing more upthrust and it will be submerged more, that is maximum portion, that is more portion of the body will be submerged in the liquid. So volume immersed inside the liquid will be greater, which means the volume of liquid that is displaced will be greater. Volume of liquid displaced with the upthrust. Okay, it is something that is affecting the upthrust, so upthrust will be greater. Okay, so we have to keep in mind, we have to have an idea about the Archimedes principle and the law of flotations. Okay, principle of flotation. So with this you can explain these two. Okay, next, a body floats in liquid of different densities only when the density of the body is less than or equal to the density of liquids. With this we have discussed. So for a body to float, two cases are when the density of the liquid is greater than the liquid density of solid, or the density of liquid is equal to the density of solid. So when the density of liquid is equal to the density of solid, it will be experiencing maximum upthrust, that is the entire portion of the body will be inside the liquid, just floating case. Okay, when the density of liquid is greater than the density of solid, this is a case when it will be floating in such a way that a portion, it is partially immersed inside the liquid and partially a portion will be above the liquid. Okay, now when you consider the case, you have three liquids. Okay, so density of liquid A, density of liquid B, density of liquid C. Let's say density of liquid C is greater than density of liquid B is greater than density of liquid A. Okay, so here we know that in all these cases the body will be floating. Okay, a body floats in liquid of different densities only and only when the density of the body is less than the density, less than or equal to the density of the liquid. Okay, so same body, let's say we are immersing it. Okay, so here you can see 50% is inside the liquid and 50% is outside the liquid. Okay, so density of the liquid is minimum in the first liquid A. Okay, now when it comes to B, what will happen? So here the density is greater, density of liquid is greater. So when density of the liquid is greater, the portion of the body that is immersed in the liquid will decrease. Okay, density of the liquid when it increases, the volume of the body that is immersed in the liquid will decrease. Only this much portion will be inside the liquid. Okay, now the third case, that is maximum density liquid. So here when you take, only a very little portion of the body will be inside the liquid. Okay, so the volume of body that is immersed, small letter V. Okay, in the first case, that is A will be greater than the volume of the immersed portion of the body in the liquid. B is greater than the volume of the immersed portion of body in C. Okay, that is an inverse relation. When density of the liquid increases, the volume of the body that is immersed, or the volume of the liquid that gets displaced, will be decreasing. Now, what are the applications of principle of flotation? First one is a flotation of iron ship. An iron nail sinks in water while a ship floats. So now we'll be explaining this. So when you place a small iron nail on the surface of a liquid, what happens? It will immediately sink. Okay. We know that the weight of an iron nail, the mass of an iron nail will be in milligrams. Very small. Okay. But what is the case of an iron ship? In case of an iron ship, although it weighs tons, you can see that it is floating on the surface of water. So why is it happening? This is because inside the iron ship there are empty spaces. So here you can see the presence of air. Okay, air will be inside. So when air is inside, what happens? The average volume increases. Okay, because of air there is a volume. Okay, therefore the average volume increases. Now it is not just the volume of iron, but also the volume of air is included. Okay, when the average volume increases, what happens to density? Density decreases. We know this, right? So when we have take the relation, density is equal to mass divided by volume. So when volume increases, density decreases. So density of this body is decreasing. Okay, so when the density of a body is decreasing, okay, so when you compare, the density of the body will be less than or equal to. Density is less than or density is equal to the density of liquid. In both these cases, the body will be floating. Okay, now you can see it is not, the body is not completely inside the liquid. Okay, it is not like just floating condition. It is floating with only a small portion inside the liquid, which means this is the case. That is, density of the body is less than the density of liquid. So density of body here includes the iron and the air that is contained. Okay, so density of body is less than the density of liquid, and because of this reason it will be floating. Now when the body is on the surface of liquid, you can see that only a small portion, even though only a small portion is immersed in the liquid, that is, water will get displaced. So the weight of the water that is displaced will be equal to the weight of the body. Okay, so this is a first application when you take the case of an iron nail and the case of an iron ship. Okay, so even though mass of iron ship is greater, you can see that iron ship will float and the iron nail will sink. So an loaded ship is submerged more while an unloaded ship is less submerged. So when cargoes are loaded in a ship, what happens is weight of the ship increases. Weight of ship increases. So when weight increases, what does it mean? So weight is increasing. Okay, so we have a balance between the weight and the upthrust. Only then the floating will be happening. So when weight becomes greater, the downward pull is becoming greater. So the portion of the body that is submerged will be higher. Okay, so here this much portion is inside the liquid, which means this much portion of water, this much weight of water will be displaced. So it will be in such a way that in a balance that the weight of liquid displaced is equal to the weight of the ship with the cargoes. Okay, so when you take the case of an unloaded ship, in the unloaded ship the weight is less. Okay, so only this much portion is submerged inside the liquid. The weight of liquid displaced balances the entire weight of the body. Okay, so this is the second application. Next, a ship begins to submerge more as it sails from sea water to river water. So here what is happening, to understand, take this example. Okay, you take a glass of water, fresh water, and put a body, a bowl or something like that, a lemon or something. We can see that since the density of the body is greater than the density of liquid, okay, density of body is greater than the density of liquid, what happens? The body will sink. Okay, now when you are adding salt to this liquid, what happens? When salt is added, the density is increasing. So when density increases, once the density of body becomes equal to the density of liquid, or the density of the body is less than the density of liquid, in those cases the body will start floating. Yes, it will start floating. Okay, so we'll take 2 spoons of salt first and then 4 spoons of salt. Okay, here what is happening? The second case, the first case density is, in the case of fresh water, will be less than the density in the second case, will be less than the density in the third case. Okay. Now, when you keep on adding salt, what is happening? The body will start to rise. Okay. So, when the density of the liquid increases, what is happening? Density of liquid increases, the portion that is submerged is decreasing. Submerged portion decreases. The part of the body that is inside the liquid is decreasing when the density of liquid is increasing. Okay. So, a ship begins to submerge more as it sails from sea water to river water. So, when you take sea water and river water, where is the density higher? So, density of river water is less than the density of sea water. Okay. So, initially the ship is in the sea water. So, if the body is coming from a region that is of higher density to a region of lower density. Okay, when it is, the density is decreasing, density of the liquid is decreasing, what happens? The submerged portion increases, and this is why the ship begins to submerge more. Okay, so it is not necessary that we have a river water only. So if the body is moving from sea water of higher density to a sea water of lower density, since the density of the liquid is decreasing, the portion of the body that is submerged will be increasing. Okay. With this example only, if you have this example in the mind, you can easily answer this. Next is Plimsoll line. So in the case of ships, there will be a white line. Okay. This means that this is the safe limit up to which the ship will be loaded. Okay, so when the ship goes into a sea water, what happens to the density? Density increases. So when density increases, the portion of the ship that is submerged will be decreasing. Submerged portion decreases. Okay, which means the level of water, okay, the level of water and the Plimsoll line, initially they will be coinciding. So when you go to a sea water, what happens is the level of water will be decreasing. Okay, so here you will be having Plimsoll line, maybe the level of water is up to this. So here this is a safe limit. If it is like you have the no limits for it, okay, if you have no limits and you are loading it completely, so when you go into the sea water, it is not that safe. Clear? So this is about Plimsoll line. An unloaded ship is filled with sand at its bottom. So why is it done? So when you take the case of an unloaded ship, okay, in case of an unloaded ship, the volume of ship submerged is very small. Okay. So here the center of gravity will be higher and the equilibrium will be unstable. So in this case, when a strong wind, when there is a chance of a strong wind, what happens is the ship will blow off. Okay, it will fly off. So to avoid this, what can be done is sand or stones are put inside the ship. Okay, so here it gets loaded. So when it gets loaded, what happens? It can get submerged. Okay, more volume of the ship will get immersed in the water. It will be submerged inside the water. So you can prevent the danger. Next is the flotation of human body. Now, average density of a human body depends upon the bones, density of bones, then the density of blood, muscles and fat. So all these constitutes the density of human body. Okay. It also depends upon the volume of air inside the lungs. Okay. So when you inhale, what is happening? When you inhale, the volume of air inside the lungs is increasing. When volume increases, what happens to density? Density decreases. Yes. So here what happens is, so when you don't inhale, in that case, the density of the lungs will be equal to 1.07 gram per centimeter cube. So when you inhale, what happens? The volume is increasing, density is decreasing. Density will be 1 gram per centimeter cube. Okay. So during swimming, like all other objects, the body can float easily. It's only when the lungs is filled. That is, before swimming, you can see the swimmer will be inhaling air. Okay. So the lungs is filled with air. Okay. Then it is in such a condition that the mouth and the nose is just above the water surface. Okay. In that state, he will be able to swim easily. He can float easily in water. Okay. So this is a flotation of human body. Next, it is easier for a man to swim in seawater than in fresh water. So what is the reason which is having greater density? Density of seawater is greater than the density of river water. In which case swimming will be easier. Swimming will be easier when he is able to float easily on water. Okay. So when the density increases, volume of body submerged will be decreasing. So he will be able to float easily in seawater. When you take the case of seawater, the density is 1.026 gram per centimeter cube. What about the fresh water? It is just 1 gram per centimeter cube. So you can see the density is higher. So the volume of the body submerged will be less in case of seawater. The amount of water displaced, the volume of water displaced, the weight of water displaced will be small comparatively. So this volume of water displaced will be able to balance the entire weight of the body. Okay, so it is easier to swim in seawater. So it is very easy to swim when you take the case of Dead Seas, to swim in Dead Sea. So here the density of water is just 1.16 gram per centimeter cube. So the density has again increased, which means the volume of the body that is submerged in the liquid will be less, okay, compared to other cases. Next is the flotation of submarines. Submarines are fish-shaped. It will be having ballast, that is flotation tanks in the front and back. Also there is a periscope. This periscope, using the periscope, the diver will be able to see the outside surface of water. Okay. So here what happens is, it can easily, that is the submarine can move inside water and outside water easily because of the presence of the ballast tanks. Okay. So here what happens is, once the ballast tanks, if the submarine should go inside water, okay, what the diver do is, he will open the ballast tank. When the ballast tank opens, what happens is, seawater will get inside. Okay. When seawater gets inside, the density of the submarine, what happens? It increases. When the density of submarine increases compared to the density of seawater, the body will start moving down. Okay. Now, if you want to raise it up, what can be done? He can open the ballast tank, okay, and the water can be released outside, then air enters. Okay. When air enters, what happens to the density? Here the density will be decreasing. Density when decreases, what happens? The body will start rising. Only a small portion will be inside the water. Okay. When only a small portion is inside the water, which means the amount of water displaced will be able to balance the weight of the submarine. Okay. So this is a flotation of submarine, which is again the application of principle of flotation. Flotation of iceberg. What is iceberg? So huge masses of ice are together called icebergs. Okay, we know that the density of ice is less than the density of water. Density of ice is approximately 0.917 gram per centimeter cube, and that of water we know that is 1 gram per centimeter cube. Okay, so ice will be able to float on the water surface with, in case of iceberg, a maximum portion of it will be submerged inside the water. Now you can find the volume of iceberg above the water surface while floating. For this, we will be having the volume of iceberg submerged. Volume of iceberg submerged. Let it be equal to small letter V. Total volume is equal to capital V. Okay. Now, density of ice, rho I, and density of liquid, rho L. Okay. Then, we know that the weight of the body will be equal to the weight of liquid displaced. So, here what is the weight of the body? Weight of the body will be equal to capital V into density of the body, that is density of iceberg, into acceleration due to gravity. Okay. Now, the weight of liquid that is displaced will be equal to the volume of liquid displaced, that is volume of iceberg that is submerged, into density of the liquid into acceleration due to gravity. Okay. So, acceleration due to gravity can be cancelled. You will be having small letter v by capital V is equal to density of iceberg divided by the density of water, density of liquid. Okay. So, this is how you will be able to find. Okay. Which means the density, which means the volume of the body, that is volume of iceberg that is submerged, will be equal to density of ice divided by the density of water. Here the liquid is water into the volume of the total volume of the iceberg. Okay. So, from this we get the submerged portion. So, to find the portion that is above, okay. So, volume of iceberg above the water surface. How can you find? So, above water surface, volume will be equal to total volume minus the volume that is submerged, that is rho I divided by rho L into capital V, or V into 1 minus rho I by rho L. Okay. So, this is how you can find the volume that is above the volume of iceberg that is above the water surface. Let us take an example. An iceberg, density of ice is equal to 0.917 gram per centimeter cube, floats on water, density of water is 1 gram per centimeter cube. With volume V is equal to 0.917 capital V. What percentage of it is below water surface? So, how to find? We know that volume of the iceberg submerged divided by total volume of iceberg is equal to density of ice divided by density of water. So, if you want it percentage, you will have to multiply with 100%. Okay. So, here what is the density of ice? 0.917 gram per centimeter cube divided by density of water is 1 gram per centimeter cube into 100%. Okay, gram per centimeter cube is cancelled, then you will be having 0.917 into 100%, which means 91.7%. So, 91.7% is below water surface. Now, what portion is above water surface? How to find? 100 minus 91.7. Okay, 100 minus 91.7, you will be getting 8.3. So, 8.3% is above water surface. Okay, 8.3% is above water surface. Clear? Icebergs are dangerous for ships. So, we have understood that in the case of iceberg, about 90% of it is below water and only 10%, approximately 10% is above water. Okay. So, depending on the density of seawater, what happens when the density of water increases? What happens to the submerged portion? Submerged portion will be, submerged part will be decreasing. Okay. Now, if the density of the seawater is decreasing, what happens? Then the submerged part will be increasing. Okay. So, for a ship, it is very dangerous because he won't be able, the ship cannot predict how much of it is inside water and outside water. Okay. So, it can collide with the iceberg and cause a huge damage. Clear? So, this is a reason. This is a danger of iceberg. to a ship. No change in level of water on melting a floating piece of ice. So when a floating piece of ice melts, what is happening? Density of ice is not changing, density of water is not changing. So what happens is the volume of the body contracts. That is, the volume of the body is decreasing. Yes, when the volume of body decreases, what happens to the submerged portion? The submerged portion will just increase. Okay, so since the submerged portion increases, it is not causing any rise in the level of water. It is just the submerged portion will be increasing, the level of water will be the same. Okay, it won't be affected when the ice melts. Next is the flotation of a fish. In a fish, there is a part called swim bladder, okay, which helps in floating. Now here, what happens is, when the fish wants to go up in the water or move down in the water, okay, what happens is, oxygen gas that is inside the blood, it diffuses and fills inside the swim bladder. So when it fills in the swim bladder, what is happening? The volume is increasing. When volume is increasing, density decreases. So when density decreases, what happens? The fish will be able to rise. Okay, because here the weight and upthrust, when compared, the upthrust is increasing. Upthrust increases and the body will move up. Okay, so the fish will be able to swim easily. It will be able to float. Now, when it needs to go inside the water, what happens is, it will open the swim bladder and allow the oxygen to go out. Okay, so when oxygen goes out, what happens again? The volume will decrease. When volume decreases, average density will increase. Okay, when density increases, the upthrust will be decreasing. Okay, the volume of water displaced will change. Okay, so when the upthrust decreases, what happens? The fish will be able to go inside the water. So this is what happening. Okay, this is about the flotation of fish. Rising of balloon. Now consider a balloon which is filled with gases like either hydrogen gas or helium gas. Okay, which is having a density that is less than the density of air. Now what happens? Outside you have air. So inside the balloon we have a gas of density that is less than the density of air. Now when you have a body of density less than the density of water, okay, what happens to the body? We know that the body will be floating. So same thing will happen because here upthrust is acting. Weight of the body is less than the upthrust. Okay, and the body will be rising. So same thing is happening here. The weight due to the gas that is exerted down will be less and the upthrust that is exerted by the surrounding air on the balloon will be greater. So it will be moving up. Now, do you think it can go to great heights? That is, it can rise indefinitely? No. Here what happens is, when you go to higher altitude, what is happening to density? Density of air will decrease. Yes, density of air will decrease. So we know that until upthrust is greater than the weight of the body, it will be able to rise. So we have said, when a body moves from sea water to river water, what is happening to density? So when you compare, the density of sea water is greater than the density of river water. So density is decreasing. So submerged portion, what happens? Submerged portion will be increasing. Right? So here when density decreases, submerged portion will be increasing. Okay. Now what happens in this case? Here when the density of the air around is decreasing. Okay, when the density of the air around is decreasing, what happens? It will not be able to rise to further heights, because here in this case, we know that upthrust is equal to the weight of the fluid that is displaced. So here it is the air, so we have to mention fluid. Okay, fluid that is displaced. So here what happens is, when the upthrust becomes equal to the weight, it won't be able to displace further. In that case, it will become, that is, it will stay at that level. It won't be able to rise further. Okay, so this is a case of rising of balloon. Second example, a block of wood of volume 25 centimeter cube floats on water with 20 centimeter cube of its volume immersed. Calculate the density and the weight of the block of wood. Okay, so here we have the principle of flotation. According to the principle of flotation, the volume immersed divided by total volume of the body will be equal to density of the body divided by density of liquid. Now try to fill. So here we have to calculate the density of the body. One thing. Okay. Then the weight of block. Weight of the solid also should be calculated. So to find the density of solid, we have the volume that is immersed given, that is 20 centimeter cube. Volume of the body we know, that is volume of block is 25 centimeter cube. Density of liquid, here we are using water. Density of liquid will be 1 gram per centimeter cube. Now put the values to find rho S. Rho S will be equal to small v by capital V into rho L. Small v, what is small v? Small v is 20 and capital V is 25 into rho L is 1. So 20 by 25, 4 divided by 5, which is equal to 0.8 gram per centimeter cube. So the density of the body is less than the density of water. Okay, so it will be floating. Next, we have to find the weight of block. So weight of block will be equal to volume of block into density of the block into acceleration due to gravity. So here the volume of block is 25, density is 0.8 into G. Okay, 25 into 8. What is 25 into 8? 200. So putting a point, you get 20.0 G. Okay, this is equal to, weight will be equal to 20.0 G, or you can say 20 gram force. 20 gram force is the weight. Okay, let us do problems from exercise 5C. Question 1 of exercise 5C. A rubber ball floats on water with its 1/3 volume outside water. What is the density of water? If 1/3 is outside water, then what is the portion inside water? Inside water volume we have to find. Let us take the volume of the rubber ball as capital V. Okay. So outside water 1/3. 1/3 into V is volume outside. So what is volume inside? It will be equal to total volume minus the volume outside, 1/3 V, which is V into 1 minus 1/3 is equal to 2/3 V. So 2/3 is the volume that is inside. We have to find the density of rubber. We have small v by capital V is equal to density of the body by density of liquid. Okay, so small v is the volume that is inside. What is the volume inside? 2/3 capital V divided by total volume capital V is equal to rho S, that is the density of the solid, which we have to find, density of the rubber ball divided by density of liquid. Okay, so density of the solid ball will be equal to, cancelling V, 2/3 into density of the liquid. So here the density of liquid 1 gram per centimeter cube. It is water. Okay, it floats on water. It is given. So water's density is 1 gram per centimeter cube. So how much do we get? Rho S is equal to 2/3, 0.6667 gram per centimeter cube. Okay. So if you need to convert it into kilogram per meter cube. So how to do? We have 1 kilogram per meter cube is equal to 1000 gram per 10 raised to 6 centimeter cube. Okay, 1 meter is 100 centimeter. Therefore, 1 meter cube will be equal to 100 into 100 into 100, that is 10 raised to 6 centimeter cube. Okay, so from this we get 1 kilogram per meter cube is equal to 10 raised to minus 3 gram per centimeter cube. So 1000 divided by 10 raised to 6. 10 raised to 3 by 10 raised to 6, which is 10 raised to minus 3. Okay, 10 raised to minus 3 gram per centimeter cube. So here we have in gram per centimeter cube. So 1 gram per centimeter cube will be equal to 10 raised to 3 kilogram per meter cube, which is equal to 0.6667 into 10 raised to 3 kilogram per meter cube, equal to 6 166.7 kilogram per meter cube. So this is the density of rubber board. This is the density of rubber board. Clear? Question 3 of exercise 5C. A wooden cube of side 10 cm has mass 700 gram. What part of it remains above the water surface while floating vertically on the water surface? So here we are given the mass of wooden cube equal to 700 grams. What else is given? Side is given. Side is equal to 10 centimeter. If side is 10 centimeter, then what is the volume? Volume of a block will be equal to side into side into side. Okay, this is a cube. So 10 centimeter into 10 centimeter into 10 centimeter, which is 1000 centimeter cube. Okay, so this is a volume. Now we can find the density of wooden block. Density of wooden block is equal to mass by volume, which is here mass is 700 divided by volume is 1000. Therefore 0.7 gram per centimeter cube is the density. Okay, we obtained density. Now we have volume of wooden block immersed divided by total volume equal to density of wooden block by density of water. Okay. So here density of wooden block. What is the density of wooden block? We have determined, which is equal to. So this will be equal to 0.7 divided by density of water is 1. Okay. So volume of immersed part by volume, total volume is 0.7 divided by 1. So this is the required fraction. Okay. What does it mean? 0.7. Okay. If the side is 1 centimeter. Okay, if the side is 1 centimeter, 0.7 centimeter will be immersed. Okay, remaining will be above the water. So here we know 10 centimeter is the side of the block. Okay, what does it mean? 0.7 means it is 70%. Okay, so 70% is immersed. If 70% is immersed, then the remaining 30%, total 100%, 70% is immersed means 30% will be above water. Okay, so we have to find. Here we have a block of 10 centimeter, 30% of 10. What is 30% of 10? 30 by 100 into 10, which is equal to 3 centimeter. So 3 centimeter of this block is above the surface, water surface. Understood? 3 centimeters above the water surface and the remaining 7 centimeter is immersed in the water surface. That's all for today. In today's class, we have discussed about flotation, the applications of flotation and how to find the volume that is submerged inside a liquid. Okay, we also solve questions from exercise 5C. Hope you all enjoyed this session. I'll be back in the next session. Until then, stay tuned to Learnohub. Learnohub free hai, par best hai. Thank you.